Some of the largest machines moving through American towns right now are freight trains stretching 2, even 3 miles long, weighing as much as a fleet of jumbo jets. And they keep derailing. A 2.3-mile Union Pacific train jumped the rails in Idaho. 31 cars scattered. Federal investigators blamed the train's own length and how it was put together. Union Pacific calls safety its top priority. Its own rule book is supposed to prevent exactly this. Yet the company posted $6.4 billion in net income in 2023 by running longer, leaner, and faster. The question isn't whether these trains are too long. It's why the railroad, whose own rules say so, keeps building them anyway. The blueprint for Union Pacific's daily operations is a dense, highly specific document known as the System Special Instructions, stamped with official effective dates like the November 2024 update. This manual serves as the railroad's ultimate safety defense. Specifically, Item 5 dictates car placement and train makeup, placing strict limits on mixing heavy and empty cars to prevent physical derailments on curves. Item 6 establishes maximum gross weight limitations, setting precise boundaries to ensure the air brakes on every car can communicate and stop the train. These are strict, calculated physical limits designed to manage the immense forces of a moving freight train. Publicly, the company presents this rulebook as Holy Writ. Union Pacific regularly markets itself as a safety-first institution, telling communities and federal regulators that its operations are built on a culture of absolute compliance. Corporate messages assure the public that every train is carefully monitored and that safety is never sacrificed for speed or capacity. Yet the trains consistently rolling out of regional yards tell a different story. The railroad routinely produces consists that push directly against the margins these rules were designed to protect. When a manifest train stretches past 10,000 feet, the mechanics of train handling shift. Long strings of light, empty cars coupled in front of heavy blocks can easily buckle under tension, a physical phenomenon the rulebook is meant to outlaw. By continuously assembling trains that test these physical boundaries, Union Pacific operates in a gap between its written standards and its active practice. The rules are on paper, but the trains on the tracks show a system that operates in a state of self-contradiction. This represents a systematic choice to prioritize operating metrics over the very safety margins the railroad's own engineers calculated. On September 17, 2018, Union Pacific executives announced a sweeping structural overhaul called Unified Plan 2020, scheduled for launch on October 1st. This overhaul was the formal rollout of precision scheduled railroading, an operating philosophy that treats a freight network like a highly synchronized, scheduled airline. The plan targeted an aggressive 60% operating ratio by 2020, with a long-term goal of 55%. In railroad economics, the operating ratio measures expenses as a percentage of revenue. A lower number represents a highly profitable, asset-light business. To reach these targets, the company reorganized its entire transcontinental network around continuous motion and leaner operations. Under precision-scheduled railroading, the historic practice of holding freight cars until a dedicated train was fully assembled was abandoned. Instead, the strategy shifted to moving cars on fixed schedules, demanding constant movement. Corporate filings with the Securities and Exchange Commission describe this as a shift from moving trains to moving cars, indicating that the schedule of the cargo took precedence over the actual composition of the train. To drive down operational expenses, the railroad began cutting crew sizes, eliminating intermediate switching yards, and removing thousands of locomotives from active service. Yet the volume of freight remained. To move millions of tons of cargo with fewer engines and fewer crews, Union Pacific had to consolidate. The only way to maintain volume while cutting costs was to assemble longer, heavier trains. The growth of train lengths was the direct, predictable outcome of this design. It was a structural change that turned the traditional freight train into a multi-mile profit engine. Inside the company's Omaha headquarters, performance metrics were realigned to reward this consolidation. Executive compensation and management bonuses became tied to operating metrics like train mile throughput. This metric tracks how much cargo moves per mile, penalizing managers who run shorter, lighter trains that require separate crews and independent locomotives. The financial incentives made it clear that performance was defined by carrying capacity per trip, rather than the physical handling limits of the train. Consequently, dispatchers and yardmasters faced intense pressure to combine manifest runs, stacking empty cars and heavy boxcars into singular, sprawling consists. These massive consists were the deliberate, calculated product of an operating model designed to prioritize asset utilization above all else, embedding the physical risks of ultra-long trains directly into the railroad's financial strategy. This consolidation represents a calculated profit strategy rather than a mere operational preference. To Wall Street, moving cargo on a single, multi-mile train that once required several shorter trips is pure efficiency. This practice slashes fuel consumption, removes locomotives from service, and eliminates entire crew shifts in one stroke. The financial return on this operational stress is massive. In 2023, Union Pacific posted $6.4 billion in net income, while its operating ratio improved to 60.9%. In the rail industry, this ratio is the ultimate metric of performance, measuring expenses as a percentage of revenue. A lower number indicates a highly profitable, asset-light business, and running longer trains is the fastest way to drive that percentage down. When a single crew pulls 2 miles of freight, the savings flow directly to the bottom line, satisfying institutional investors who demand ever greater efficiency. For executives, these financial results justify the physical strain placed on the physical network. The complex physics of draft forces and coupler limits are treated as secondary issues compared to the logic of the balance sheet. To investors, a 60.9% operating ratio is proof of a highly optimized system. On the ground, however, that optimization creates an environment where physical safety margins are squeezed to secure financial rewards. A freight train stretching over 2 miles is not a single, solid machine. It is an assembly of individual steel cars connected by couplers, behaving as a complex, shifting chain of kinetic forces. Every acceleration, deceleration, and brake application ripples through this chain like a shockwave. AR brakes on a train rely on a standard 90-pound per square inch pneumatic pipe running from the front locomotive to the final car. When an engineer applies the brakes, a reduction in air pressure must travel the entire length of the train. On a conventional train exceeding 150 cars, it can take up to 3 seconds for this pressure signal to reach the rear. During this delay, the front of the train slows down while the rear continues pushing forward at full speed. This lag generates massive compressive forces, sometimes exceeding 200 kilonewtons of energy, slamming into the middle of the consist. If the air pressure drops unevenly, the system experiences a pressure sag between the locomotives and the end of the train. A drop of more than 15 pounds per square inch is interpreted by the valves as an emergency, triggering an unintended emergency brake application. This sudden, violent braking can cause a cascading failure as forces collide in the middle of the train. The danger intensifies when heavy cars are placed behind empty ones. If a block of loaded 80-ton boxcars is positioned at the rear and light, empty flat cars are in the middle, the train becomes physically unstable. When the train slows down, the heavy rear cars act as a massive battering ram, compressing the lighter cars ahead of them. When this compression occurs on a curve or a descending grade, the lateral forces can easily overwhelm the physical limits of the tracks. The immense pushing force from behind squeezes the light middle cars, forcing them upward and outward off the rails. The train tries to straighten itself out like a string being pulled taut, causing a phenomenon known as string lining. This danger is a direct physical mechanism, dictated entirely by weight, velocity, and friction. When economic incentives demand longer consists, they push the steel couplers, airlines, and track geometry to their absolute limits. On June 17, 2020, at 8:24 p.m., westbound Union Pacific freight train MNPPD-16 was rolling through Bancroft, Idaho. This was not a standard freight run. The consist stretched 2.3 miles from end to end, a massive wall of steel weighing thousands of tons. Traveling at 35 miles per hour on the Pocatello subdivision, the massive train experienced a sudden, violent physical failure. In an instant, 31 cars piled off the tracks, leaving a twisted wreck of steel. While the railroad's public relations campaigns frequently emphasize a flawless, safety-first culture, the Federal Railroad Administration's official investigation into the accident, Report HQ 2020-1488, tells a completely different story. Investigators did not point to an external act of God or a sudden failure of the track. Instead, they identified the primary cause as code H504, excessive buffing or slack action, directly linked to the way the train was put together. The complex physics of train forces became a destructive reality on the ground. The immense, shifting forces of a 2.3-mile consist proved too much for the train's couplers to handle, buckling the midsection under intense compressive pressure. But the federal documentation revealed an even more troubling systemic failure. The FRA cited contributing cause H599. The locomotive engineer had not received any additional training before being assigned to operate a train of this extreme length and tonnage. Union Pacific had put an uncertified crew member at the controls of a monster train that substantially exceeded their previous qualifications. This case stands as a documented failure where operational decisions overrode basic engineering safety margins. When a multi-mile train is assembled with uneven weight distribution and handled by an untrained crew, physical limits are breached and disaster is no longer a theoretical risk. It is a documented reality. On June 19, 2019, at 9:49 in the morning, westbound freight train MNPRV-17 was descending a 1% grade on the Lakeside subdivision near Wells, Nevada. This consist stretched 11,866 feet and weighed 16,501 tons. Up front were 3 locomotives, assisted by 2 mid-train remote units, pushing 120 loaded cars and 56 empty cars. As the train moved at 38 miles per hour, the physical forces of this massive makeup collided. The heavy rear cars acted as a battering ram, pushing the light, empty cars in the middle directly off the tracks. 27 cars derailed. The Federal Railroad Administration's investigation, Report HQ 2019-1344, pointed directly to the train's extreme length and improper makeup as primary contributing factors. It was a string-line derailment where physical limits were overwhelmed by the sheer scale of the train. Coming exactly 1 year before the Idaho disaster, this second federal investigation turned a single wreck into a clear, documented pattern. It showed that when Union Pacific runs multi-mile consists with volatile weight distribution, the risk of structural failure becomes a predictable certainty. Operating a multi-mile freight train requires entirely different skills than a standard consist. The physics of managing slack, brake pipe pressure propagation, and undulating terrain forces demands precise technical adjustments that go far beyond standard locomotive qualifications. The engineer must constantly calculate the delayed reaction of the air brakes and the immense longitudinal forces of slack action, where a single miscalculation can buckle the train's midsection. Yet federal records reveal that Union Pacific routinely placed engineers at the controls of these massive consists without the required preparation. In the formal investigation into the Idaho derailment, the Federal Railroad Administration documented that the locomotive engineer had received no additional training before operating a train that substantially exceeded their previous qualifications. This omission occurred despite clear regulatory standards. The Federal Railroad Administration's 2023 Safety Advisory explicitly called on major railroads to update engineer training programs to address long train-specific handling practices, particularly managing the severe in-train forces that occur during braking. Union Pacific's own internal certification files mandate special qualification processes when a train's length and tonnage increase. However, the gap between written policy and yard assignment remains wide. When an untrained engineer is tasked with managing thousands of feet of shifting steel, the physics of string lining and coupler stress become highly unpredictable. This deficiency makes the documented accidents look entirely preventable. They are the predictable consequence of sending crews to operate ultra-long trains without the advanced training that both federal regulators and the railroad's own safety guidelines require. When frontline workers attempt to enforce safety rules by flagging equipment defects or requesting slow orders on massive consists, they face immediate resistance from management. Internal records and court filings show employees being berated, written up, furloughed, or fired for prioritizing safety over schedule speed. In one landmark case, track maintenance worker Brian Peterson was terminated after reporting unsafe conditions. An administrative law judge ruled that Union Pacific systematically misused its safety guidelines to punish legitimate reporting rather than protect its workers. The court ordered Peterson's immediate reinstatement and awarded him over $325,000 in damages. This pattern of retaliation extends deep into the ranks of locomotive crews. In 2024, the Occupational Safety and Health Administration ordered the railroad to pay $350,000 in punitive and compensatory damages to a locomotive engineer. The engineer had been threatened with discipline simply for reporting that he was too ill to operate a train safely. Another OSHA investigation that same year found Union Pacific intimidated an engineer who reported health symptoms including a migraine, blurred vision, and dizziness. OSHA ordered the carrier to pay a $20,000 punitive award, along with $3,500 in compensatory damages and attorney fees. The financial penalties reached an unprecedented peak in the case of former employee Mark Granis. After Granis suffered a shoulder dislocation, Union Pacific terminated his employment. Granis filed a federal lawsuit alleging Americans with Disabilities Act violations. A jury returned a massive $25 million punitive damages verdict against the railroad, alongside $509,849 in back pay. These administrative and judicial rulings expose an operating environment where reporting a hazard, an illness, or a physical limitation is treated as an offense worthy of termination. The pressure placed on individual workers is the direct result of institutional incentives designed at the corporate level. Union Pacific measures managerial performance through strict efficiency metrics, linking quarterly bonuses and advancement to how quickly rail cars move through terminal yards. Under this system, a manager is penalized when a train sits idle, regardless of whether that delay was caused by a safety inspection. Defect tolerance is not part of the bonus structure. To keep the network moving, supervisory pressure flows downward. Internal logs and regulatory complaints reveal that terminal managers actively coached yard workers on how to answer questions from Federal Railroad Administration inspectors. Employees reported receiving explicit instructions to keep their heads down and avoid initiating detailed checks. When inspectors arrived, workers faced direct demands to let minor mechanical issues slide, with supervisors instructing them to let the nitpicky stuff go. This interference extended directly to federal oversight. When safety inspections began to back up freight schedules, terminal managers bypassed the inspectors on the ground, calling federal agency offices directly to complain that safety audits were disrupting private commerce. The corporate incentive structure values velocity above compliance, meaning yard managers are rewarded for speed, while the inspectors trying to enforce the rulebook are treated as operational bottlenecks. This friction ensures that business pressure distorts safety oversight long before any official defect counts are ever recorded. In the summer of 2023, the Federal Railroad Administration launched a massive, unannounced safety audit of Bailey Yard in North Platte, Nebraska. Sprawling across 8 miles of the Platte River Valley, this is the largest railroad yard on Earth, sorting up to 10,000 rail cars every day. It is the central engine of Union Pacific's transcontinental network. If a systemic breakdown in maintenance existed, it would show up here. The audit's findings were devastating. Federal inspectors examined the active fleet and documented a locomotive defect rate of 72.69%. Nearly 3 out of every 4 engines inspected carried safety-critical defects, including cracked wheel sets and worn-out braking systems. The freight cars were in similar disarray, showing a defect rate of 19.93%. Both figures were roughly double the national average for Class I railroads. These were not minor compliance technicalities. They were failures in the essential mechanical systems required to hold together and stop multi-mile trains. Federal Railroad Administration Administrator Amit Bose sent a formal letter to Union Pacific leadership warning that these high defect rates posed a direct, systemic safety risk to the public. But the railroad's reaction to these physical failures alarmed federal officials even more than the broken steel. The federal agency officially described Union Pacific's response as reluctant. Instead of cooperating to pull defective equipment off the lines, local management fought back. Regulatory records and subsequent investigations revealed that terminal managers actively pressured yard workers to speed up inspections and let defects slide to keep freight moving. Supervisors instructed workers to ignore minor issues and coached them on how to answer questions from federal inspectors. When the federal audits began causing delays in the shipping schedule, managers bypassed the inspectors on the ground, calling federal agency offices directly to complain that safety audits were interfering with commerce. The tension grew so severe that the federal agency temporarily suspended its cooperative safety assessment of the railroad, citing management interference. The North Platte bombshell changed the story from a sequence of failures to a documented maintenance culture crisis. This was no longer about a few poorly assembled consists or an isolated mistake by an untrained crew in Idaho or Nevada. The world's largest rail yard had become proof of a systemic reality. Under the pressure of precision-scheduled railroading, the margins of safety had been systematically eroded. To maintain the velocity demanded by Wall Street, Union Pacific was running trains that exceeded its own safety rules, while relying on engines and cars that were physically falling apart. The Federal Railroad Administration does not systematically collect train length data in its accident reports. According to a Government Accountability Office investigation, these essential figures remain shielded from the public, leaving regulators to analyze derailment risks with massive informational blind spots. Even without official tracking, the GAO determined that average train lengths have grown by roughly 25% since 2008. When local communities attempt to address this physical hazard, they run into a wall of legal immunity. Nevada lawmakers introduced Assembly Bill 456 to cap freight trains at 7,500 feet, following several multi-mile derailments. Yet these state safety measures are consistently blocked by federal preemption. Under the Interstate Commerce Commission Termination Act, the Surface Transportation Board holds exclusive jurisdiction over rail operations. Courts routinely strike down state-level limits, ruling that local safety caps unconstitutionally interfere with interstate commerce. This legal structure creates a practical oversight vacuum. Local governments remain powerless to protect their towns, while the federal agency in charge of safety continues to operate without the basic data needed to police the rails. This regulatory deadlock is not an accident. It is the result of systematic political influence designed to protect the railroad's operating model from government interference. At the center of this defense is the Association of American Railroads, the industry's primary trade group. In 2023, the association spent more than $4.4 million on lobbying efforts in Washington, followed by another $1.3 million in the first quarter of 2024 alone. These resources are deployed directly to members of Congress on transportation committees, pushing a consistent message: there is no emergency on the tracks. The industry points to long-term safety records and argues that modern technology, like distributed power and real-time force monitoring, makes longer trains safe to run. They argue that federal caps on train length would disrupt the flow of supply chains and harm economic performance. By framing federal intervention as unnecessary and economically destructive, this coordinated campaign creates an institutional shield. This ensures that while communities face the physical risks of 2-mile-long trains, the laws that protect the business model running them remain untouched. The rail industry maintains that long trains are not inherently dangerous. Independent transportation analysts and industry supporters argue that modern technology has fundamentally redefined what a train can safely handle. At the center of this defense is distributed power. By placing remote locomotives in the middle and at the end of a 2-mile consist, and linking them via loco-trawl communications, railroads can synchronize braking and throttle commands instantly. This setup reduces the physical slack action and the brake pipe pressure lag that historically plagued long trains. Proponents also point to long-term safety data, noting that the overall train derailment rate has steadily declined over the past 2 decades. From this perspective, the physics of a 150-car train are fully manageable with proper technology and advanced braking systems. But this technical capability raises a deeper, more systemic question. The real dispute is not whether a 2-mile train can be operated safely under ideal conditions, but whether the relentless cost-cutting pressures of precision, scheduled railroading alter those conditions. When crews are downsized, maintenance is deferred, and managers are pressured to prioritize speed over safety checks. Even the most advanced safety technology can be pushed past its breaking point. Today, the relentless drive for profit keeps pushing these multi-mile behemoths through American towns. As corporate pressure routinely overrides the railroad's own safety limits, manageable physical risks are transformed into a systemic public danger. The next major derailment is no longer a matter of if, but where. Until federal oversight finally overrides Wall Street's demands, local communities will continue to bear the ultimate cost. Share your thoughts on this rail crisis in the comments.